let's begin our class, no? Since 10:37 na, para maaga yung ating lunch time. Okay, so Lewis structures. When they say Lewis structures, these are structures wherein your molecules are represented by atoms connected, no, to each other. So yun, ito ay molecular representation wherein you can see the atoms being connected to one another, no. And the connection of the atoms, no, forms the molecules, no. Okay, so we have two ways kasi to create molecules, no, or ions, no. So si lecture magdi-discuss niyan. So lecture will discuss the ionic bonding, the principle behind the ionic bonding, and the covalent bonding, ano yung history behind that, no. Okay, so ang focus natin today is, alam ko you have an idea naman already on ano yon, no, kung saan yon about, no. So we can start with the Lewis structure na, no. Okay, so again, Lewis structures, these are molecular representations where you can see your atoms connected, no, to one another, no. So yun, no. The question there is, paano tayo gumagawa ng structure? How do we create Lewis structures? So we have few guidelines to follow, no? So we will start with rule number 1. So what is the rule number 1? You have to categorize your atoms based on electronegativity. Okay. So that's rule number 1. You can categorize your atoms based on electronegativities na. So ayun. In your lecture, you already knew the periodic trends naman. So again, let's recall lang na. So yun lang naman yung gusto muna natin sa ngayon. So ayan, ayaw bumukas. Okay, so electronegativity, what's the trend? As you go to the right side of the periodic table, the electronegativity increases. Na. And as you go upwards sa periodic table, the electronegativity also increases. The question is why? No? Why are the atoms on the right side more electronegative than those on the left side? Okay. The answer here is ganito lang, madali lang. Because atoms want to emulate something. May gusto silang gayahin. Ano kaya yung gusto nila gayahin dyan? Yung mga noble gases. So bakit ano meron sa noble gases? Bakit gustong-gusto sila gayahin ng mga atoms natin? No? Bakit kailangan may bonding? Okay. So yun nga yung reason. No? The reason why chemical bondings, no, possible yung mga chemical bonding is yun. They want to emulate the noble gas configuration. Because if they do not, hindi tayo nag-exist ngayon. Walang Earth ngayon. No? So yun yung idea. They want to emulate, no? Gusto nila gayahin kung ano yung meron yung noble gas. For example, kayo, kunwari, sino bang pwedeng sikat na tao? Gusto nyo gayahin yung favorite K-pop artist nyo. So, kunwari, gusto nyo gayahin wala akong kilala eh. Basta gusto nyo gayahin yung isang K-pop artist nyo. Ano gagawin mo? So, it doesn't necessarily mean na ikaw, Filipino ka, you will go to Korea and change your citizenship, no? Ganon din yung atoms, hindi nila gagawin yon. What I mean by that is that yung atoms natin, they will not change their identity para maging noble gas. Meaning yung oxygen, hindi siya magpapalit to neon. No? Hindi pwede yon. No? So, ganun din sa inyo. Effort masyado. Kung gusto nyo gayahin yung tao, hindi necessary kailangan maging Korean kayo. No? Or kailangan maging American kayo or any nationality. Instead, ano yung gagayahin mo? Yung meron sila. Okay? Yung mga style, yung mga damit, yung looks, no? Kakabisaduhin mo yung language, ganun din yung atoms, no? So for atoms, for them to imitate what the noble gases do is that tinitignan nila yung electron configuration. Now, balik ulit tayo sa topic ng electron configuration. Okay. So, hindi pwede yung atom ko, let's say oxygen, hindi siya pwedeng maging neon agad. Ano yung pwede niya gawin? Pwede niya gayahin yung meron si neon. Parang kayo yan. Hindi kayo pwede maging Korean pag gusto niyo gayahin yung K-popper, yung K-pop artist niyo. Instead, ang pwede niyo gawin, gayahin niyo kung ano yung ginagawa niya. Kumakanta, sumasayaw, no? So on and so forth, yung styles ng buhok, no? So yun, yung ganang ginagawa niya. So for atoms, the same is true, no? But how do they imitate the noble gases, no? So, sagot doon is through electron configuration, di ba? Sabi ko electron configuration. Paano, no? Kasi ganito. Um, our atoms can give off or accept electrons. Bakit sila nag-give off ng electron? Bakit sila nag-accept ng electron? The reason is, when they do so, they alter their electron configuration. They change the electron configuration. So as they change their electron configuration, they are assuming the noble gas configuration. Let's take for example, lithium. Sodium na lang. Asan yung, andito yung pencil ko. Balikan natin yan na. So, balik tayo kay sodium. What's the electron configuration of sodium? That's 1s2, 2s2, 2p6, 3s1. Okay. So, alamin natin yung, bago tayo pumunta doon. Ang electronic configuration natin, we can classify that into two parts. No? We have the part for the inner electrons. We have the inner electrons and the outer electrons, which we call the valence electrons. Sir, paano malalaman kung inner or outer or valence? Ganito lang. So you check the electronic configuration. So this is my electronic configuration. I want to check kung anong noble gases yung pwede ko gawin out of this. For example, 1s1, 1s2, that corresponds to a noble gas, helium. Diba? So 1s2, helium yan. Ano pa yung pwede ko pang noble gas na gawin? 1s2, 2p, 1s2, 2s2, 2p6. Ano yung, saan nagka-correspond yan? Sa noble gas na neon. Okay, so hanggang dyan lang ako. Kasi yung 3s1, hindi na ako makakagawa ng noble gas with that electrons. Diba? Okay, so the idea is that etong group na to, etong hanggang dyan sa 2p6, yan ay noble gas configuration. Yan yung aking inner electrons. No? So I can represent my electron configuration as that, as complete electron configuration, or I can condense it to, pwede ko siya paigsain, pwede ko siya gawing neon 3s1. So this one is my inner electrons, and this one would be my valence electron. So yun yung idea. So ito yung inner electrons ko, ito yung valence electrons ko. And again, sabi natin, every atom, they want to be a noble gas. No? Paano sila magiging noble gas? They can give off the electrons or they can accept the electrons. No? So looking at sodium, it would be easier for it to give off this electron. Bakit? Isa lang kasi yung electron niya. If it will accept 7 electrons, masyadong effort. No? Masyadong effort to accept 7 electrons. So, ano gagawin niya? Instead, ipapamigay na lang niya yung electron na isa. No? So, pag binigay niya yung electron na isa na yan, pag binigay niya yan, what will happen sa sodium natin? Magiging ang electron configuration niya ay neon na. Same as neon. Pero what will happen to sodium? Since it lost 1 electron, the charge will be positive 1. So that's one way for sodium to achieve the noble gas configuration. It can give off its electron. No? So papamigay niya yung outer electron niya. Then pag pinamigay niya yon, ang matitirang electron configuration niya ay yung nakay neon. So yan. So easy, 'di ba? So noble gas configuration na siya as it turns into ions. No? Another example would be oxygen. 1s2, 2s2, 2p4. Okay, so alamin natin from the electron configuration, hanapin natin yung noble gases that we can create. No? 1s2, this corresponds to helium. Hanggang helium lang. Bakit hindi pwede yung neon? Kasi 2p4 to. The ending for neon is 2p6 dapat. So kulang ng dalawang electron. Okay? So I can condense this as helium 2s2 2p4. Okay, so the question here is ganito. Paano siya magiging noble gas? No? Paano siya magiging noble gas? Would it accept or give off electrons? This time, if oxygen is going to give off the electrons, medyo effort. Bakit sinabi kong medyo effort? Tingnan nyo, ilang electrons na meron siya? 6 na. So we have 2 plus 4. May 6 electrons na siyang valence, no? May 6 na siyang valence electrons. Pag ipapamigay nyo yung 6 na yon, effort, masyadong mahirap. Ano na lang pwede niya gawin? If oxygen is going to accept 2 more electrons, what will happen to its electron configuration? If it accepts 2 electrons, what will happen is that the electric configuration will be changed, no, from S2P4 magiging 2S2 2P6 na. And 'di ba again, ito ay neon configuration, 'di ba? 'Di ba neon configuration yung 1s2, 2s2, 2p6? Okay? So that means for oxygen, for it to be stable, it needs to accept 2 electrons, no? So what will happen to our oxygen atom is that since it accepted 2 electrons, the charge will be -2. So yan. So for oxygen, it would be easier to accept electrons to assume the noble gas configuration. No? Okay, so that should give us an idea about electron affinity. No? So yun sa lecture nyo. Although itong topic na to, sa lecture talaga magdi-discuss na ito, dinaanan ko lang na. So yun, electron affinity, yun yung desire to get electrons, di ba? The reason why is ayun nga, for it to be a noble gas. So looking at oxygen, it loves to accept 2 electrons for it to be a noble gas configuration. No? Meanwhile, sa sodium, ayaw niya tumanggap ng 2 ng electrons. Bakit? For it to be a noble gas, it requires 7 more steps. No? 7 more electrons ang kailangan niya kunin, which is effort. Ayaw niya ng ganun. No? So, we can say that sodium is less electronegative than oxygen. No? So, yun yung idea. And so, dinaanan ko lang. No? Si lecture na bahala dyan, to be honest. No? So, yan. So, balikan uli natin yung lesson natin. Ba't ba ako napunta dyan? Share ko lang yan. Balik ulit tayo sa lesson. Okay, so, yan. So, yun lang yung idea, no? The reason why atoms form molecules or ions is that they want to assume the noble gas configuration. Ang focus natin ngayon is yung sa sharing of electrons, no? Okay, so sige. So, yan. So, number 1, we have to categorize your atoms based on electronegativities. Balik na ulit tayo sa lesson. Nadala lang ako ng idea ng assuming the electron configuration of noble gases na. Anyway, so balik tayo. So for Lewis structure, rule number 1 is for you to categorize your atoms based on electronegativities na. Going back sa periodic table, the most electronegative atoms can be found on the rightmost side, no? And on the leftmost side, andun yung mga hindi electronegative, no? Okay, so as you can see here sa graph natin, the electronegativity of atoms on the group 7, no? Mataas yon kaysa sa ibang groups, no? The reason is, ayun, no? Look, no? Isang step na lang sila para maging noble gas na. That means they just need 1 more electron for it to be a noble gas configuration. Kaya mas electron negative sila or mataas ang kanilang electron affinity. No? So, yun yung idea. So, ayan. As long as you know the trend, you can start categorizing your atoms based on electronegativities. We have two types of atoms for a Lewis structure. We have a central atom and we have a terminal atom. Okay, so what is the central atom? The central atom is the atom in which your terminal atoms will attach into. Sila yung kakabitan. Ah, Sila yung kakabitan ng terminal atoms. And ano yung criteria for a central atom? Central atom is usually the least electronegative atom. So by just looking at the periodic table, you can see if the atom is least electronegative kung siya ay nasa left side ng periodic table. Because remember, anything on the rightmost side, electronegative yun. No? Okay, so yun yung idea. So pag nasa left banda, central atom yan. Although, may exception yan. No? Sino yung hindi kasama dyan sa rule na yan? Hydrogen atom. Bakit hindi pwede maging central atom si hydrogen? So, the reason is hydrogen only possesses 1s orbital. Di ba 1s orbital lang meron si hydrogen? Kasi yung ginawa natin Christmas tree last time, di ba 1s lang talaga? Pag 1 energy level, s orbital lang yung kaya. And that means yung hydrogen natin, it can only accept 2 electrons, di ba? Yung 2 electrons na yon, they can be signified as 1 bond, no? So, ibig sabihin nun, hindi na pwede kabitan si hydrogen ng iba pang groups, no? Hindi na siya pwede kabitan ng ibang groups. Bakit hindi na pwede? Kasi hydrogen can only attach via single bond, no? Kasi itong single bond na to, enough na yan for the hydrogen to be stable. Yung dalawang electron sa single bond, enough na yan for hydrogen to assume the noble gas configuration. No? So, yun. So, that means hindi siya mag-qualify as central atom. Kasi isang bond lang yung kaya niya gawin. No? So, yun. That's why we exclude hydrogen. No? Sige. So, central atom is anything or any atom that is the least electronegative in your group with exception to hydrogen. Okay? Bakit bawal si hydrogen? Again, it can only accept 2 electrons. It cannot form multiple bonds. No? Hindi pwede mag-form ng multiple bonds. So, sa dulo siya. Okay? So, ano yung nasa dulo? Yung terminal atoms. No? So, when we say terminal atoms, these are our most electronegative atom. Siya yung most electronegative atom, including hydrogen. So, si hydrogen, pwede siya maging terminal for the reason na hindi siya pwede kabitan. So, siya yung kabit. No? Siya yung kumakabit. No? Hindi siya yung kinakabitan. No? So, yun yung idea. So, yun. Most electronegative dapat. No? So, that means for example, meron ka neto. So, you have this molecule, CH2O. Sino kaya yung central atom dyan? So, looking at your periodic table, tignan natin CHO. So, si carbon, ayan siya, no? Ang kanyang electronegativity ay 2.55. Si oxygen ay nasa rightmost side. Ang kanyang electronegativity ay 3.44. So, that should give you an idea. Since si oxygen ay nasa rightmost side, that means si oxygen ay terminal atom. Si carbon, since siya yung nasa left, siya yung magiging central atom. Sir, paano si hydrogen? Nasa dulong left yon. Again, no? Regardless sa position ni hydrogen, siya ay terminal atom pa rin. No? So, terminal atom pa rin yung hydrogen kahit ano mangyari for the reason that it cannot form multiple bonds. No? So, hindi siya kaya mag-form ng multiple bond because s orbital lang yung meron siya. No? So, yun yung idea. So, among the three atoms, carbon, hydrogen, and oxygen, carbon would be our central atom. So that means hydrogen and oxygen, this will be our terminal atoms. Nasa dulo sila. Okay? So, ganun lang. Na? So, that's how you categorize your atoms based on electronegativities. As long as you know the trend, you're good to go. Na? So, after categorizing your atoms, rule number 2 tayo. Ano gagawin mo doon? Create the skeleton. So, how do you create the skeleton of your structure? Ganito lang. You arrange your atoms, no? Wherein your central atom is in the middle, nasa gitna yung central atom, and your terminal atoms will be located around the central atom. H, O, H. Ganyan. So yan, ipapalibot mo yung terminal atom sa central atom. Ideally, sa 4 directions. Sa taas, sa baba, sa left, and sa right side. No? For example, we have CH4. Again, hydrogen, automatically, terminal yan. So that means your carbon will be the central. No? So how are you going to arrange the hydrogens? So si hydrogens ay nasa palibot ni carbon. Meron sa taas, meron sa baba, sa left, and sa right. So that's how you draw the skeleton. So yan. This is your central atom and these are your terminal atoms. Excuse me. So for now, 4 na terminal atoms lang muna tayo. No? Okay, so yan. So recall. Categorize your atoms, central, terminal, central, least electronegative, excluding hydrogen, terminal, most electronegative, including hydrogen. Create your skeleton in central atom in the middle. All the other atoms ay nakapalibot in 4 directions. Now, okay, so with that, we can do this new rule, NASU rule. I know, familiar, yung iba sa inyo, I mean most of you, are unfamiliar with this one. Ako rin, no? Nung college ako, hindi ko alam yung NASU rule. Kailan ko yan natutunan nung nag-review ako sa board exam, no? Sa board exam namin. So yan, ako kasi before, hate ko tong Lewis structure, no? As in, kasi parang ang ginagawa kasi natin, 'di ba, nung high school, even nung college ko dati, ginagawa namin, ayan yung dots. 6 valence electrons for oxygen, hydrogen, 1 valence electron. So, ano gagawin? Dugtong mo. So, the problem with that is, madali siya tignan. Yes. Parang madali lang. But the problem is, what if complex na yung molecule? What if may charge na yung molecule? For example, ayan. For example, ito. Ano na gagawin mo pag complex na yung molecule? When I say complex, may charges na, no? So, ayan. Paano mo i-drawing yan? So, doon na ako nalilito dati. No? So, hindi ko na kaya. Umiiyak na lang ako. De, joke lang. Kinakaya ko naman. No? Pero I'm still confused. No? Kasi sabi nila, ganyan. Dudugtong-dugtong mo daw. Tapos, bakit na naging ganon? So, nalilito ako. So, until the time I met the NASU rule. So, salamat sa mga review center professors namin. Tinuro nila sa amin yung NASU rule. Ito yung tinuturo din sa UP. No? So, yan. So, alamin natin yung style nila. NASU. Although hindi ito nag-originate sa UP, sa ibang bansa talaga ito nag-originate. So, NASU rule, it contains 4 different numbers, no, which are needed, no, to complete your structure, your Lewis structure. So, N stands for the needed electrons. A stands for the available electrons. S is for the shared electrons. U is for the unshared electrons. Pag ginugol nyo ito, makikita nyo rin yung NaSl. L stands for the lone pair or the unshared electrons. Okay. So anyway, balik tayo. NASU, needed electrons. When we say needed electrons, this actually pertains to the number of electrons the atom need in order to assume noble gas configuration. So it should give you an idea kung ilang electrons yung need ng atom for it to be a noble gas configuration. So, ano yon? So, basically, ito yung octet rule. So, ano yung octet rule again? When we say octet rule, it tells us that there should be 8 electrons, di ba? For the atom to be stable or to assume the noble gas configuration. Bakit? Ganito kasi. Balik tayo sa periodic table. Let's look at the periodic table. By the way, please don't mind the D and the F orbital. Hindi natin sila papansinin this time because the rules are different for these elements. No? 18 electron rule yon. So, inorganic chemistry na yun na BS Chem. So, hindi tayo abot doon muna. No? Basic lang tayo. So, look at the S and the P orbital muna. No? So, looking at the S and P orbital, remember that S can hold 2 electrons. That's why we have 2 columns here, diba? The p orbital can hold 6 electrons. That's why we have 6 columns here. So if you're going to count, how many steps do you have to take from S1 to P6? Ilang steps yung kailangan para ma-achieve mo yung noble gas configuration? Ilang steps ang kailangan daanan para mapunta sa noble gas configuration? Bilangin natin, 1, 2, 3, 4, 5, 6, 7, 8. So that should give you an idea that there should be 8 electrons needed to completely fill the S and the P orbital. That's why we have the octet rule. So ano meaning ng octet rule? 8 electrons to complete the S2 and the P6 orbital. Because once these two orbitals are complete, that means your atom now assumes the noble gas configuration. Kanino to nag-a-apply? This only applies for atoms found here sa P block natin. So that only applies for atoms that are found in the P block. No? Why? Bakit hindi siya pwede mag-apply sa S? Because again, remember, S orbitals can only hold 2 electrons. While the p orbitals, they can hold up to 8 electrons in total. 2 for the s, 6 for the p orbital. No? So that's why the the octet rule only applies to the atoms found here sa p block. Okay? And ganun naman yung mangyayari sa atin most of the time. No? Okay, so ayun, yun yung octet rule. Needed electrons, the number of electrons needed in order to assume the noble gas configuration, aka the octet rule. Na. Again, the octet rule only applies for atoms found in the P block. Nasa P block. Sir, paano si hydrogen? Nasang block si hydrogen? Nasa S block lang siya. No? 1s lang meron siya. How many electrons yung kailangan ni hydrogen? Eh di, dalawa lang. So, 1s2. So, yun yung idea. No? So, not all will follow the octet rule. Actually, may mga cases na hindi talaga masusunod yung octet rule. Next meeting yon, yung violations octet rule. Pero sa ngayon, yung simple lang muna tayo, ha? Okay. So, now, alam natin, yung nagva-violate ng octet rule, isa doon si hydrogen. Bakit? Looking at hydrogen, it doesn't have p orbitals. So, hindi niya mapupuno itong p6 na yan. No? So, dalawa lang yung electrons na need niya. Okay? So, that's the end for the NASU rule. Meron na lang tayong ASU, available. So, when we say available electrons, this pertains to the valence electrons. Question, how are we going to predict the valence electrons? You can do yung ginawa natin kanina. Yung, for example, you have sodium 11, 1s2, 2s2, 2p6, 3s1. Kunin mo yung mga noble gas na kaya niya gawin. Ano yung mga kaya niya gawin? Helium, ano pa? Ito, neon. So, you can condense that as neon, 3s1. Itong nasa labas, that is your valence electron. But again, hindi nagpakahirap si Dimitri para gawin pa natin yan uli. Bakit? By just looking at the periodic table, we can actually predict the valence electrons. So that means hindi na necessary itong ginagawa natin ito. No? Because we can just look at the periodic table, identify to which group it belongs, and yun. So we can solve for the valence electrons. Tingin tayo. Again, do not mind the D and the F orbital. SNP lang tayo. Okay? Sige. So looking at our periodic table, we have main groups and the minor groups. Ang minor groups ay yung D and F orbital. So hindi natin bibigyan ng pansin yan. Instead, we will just look dito na ayan sa mga yan. In your periodic nahikab ako. Gusto ko umikab tapos nagsalita. Balik tayo. In your periodic table, this is the first group, di ba? Ito yung 1A. Yung nasa taas niya, 1A yan eh. So, itong elements na yan, since that is group 1, the ending, no, yung kanilang, valence electrons ay isa lang, S1. 1s1, 2s1, 3s1, 4s1, 5s1, 6s1, 7s1. So, yan. So, iisa sila ng valence electron. Ilan? Isa. For group 2A, ito yung may mga valence electrons na dalawa. Asan yung dalawa yon? Nasa S2. 2s2, 3s2, 4s2, 5s2, 6s2, 7s2. So, yun. So, dalawa yung kanilang valence electrons. Ito yung group 3. I-jump mo itong transition metal. Huwag nyo sila pansinin. Ito yung group 3A. So, for the third group, ilang valence electrons meron? Siyempre, nadaanan niya yung s orbital. So, meron siyang S1, S2, S2P1. So, ilang electrons yung sa S2P1? Ayan o, S2P1. So, ilang valence electrons yan? Tatlo. So, for group 3, tatlo. Group 4, 4, 5. For group 5. Group 6, 6. Group 7, 7. Group 8, 8. So, ganun. By just looking at the groups, you can predict the valence electrons. Isang valence electron, dalawang valence electron, tatlo, 4, 5, 6, 7, 8. Hanggang 8 lang. Okay? So that's the technique. You just check kung anong group siya sa periodic table. Kung anong group number, that's the valence electrons automatically. Okay, so nothing to worry too much. No? Shared electrons. So when they say shared electrons, these are the electrons used in bonding. Used in chemical bonds. No? So ilang electrons yung ginagamit for a chemical bond? No? So ano ba yung chemical bond? Nakikita nyo yun as lines. No? May mga ganyan kayo makikita. Question, ilang electrons yan? Sa isang bond, may dalawang electrons doon. One bond, 2 electrons. Okay? So, dalawang electrons kada isang bond. No? Sir, paano namin malalaman kung gaano karaming electrons ang isi-share? Ganito yung formula, N minus A. So, when you subtract the available electrons from the needed, or N minus A, makuha mo yung shared electrons. Kung ilang electrons yung gagamitin nila for bonding. If you divide it by 2, you will get the number of bonds. Mamaya may examples tayo. Marami. So, mauumay kayo. Okay? Then, moving on, last one, unshared electrons. When you say unshared electrons, these are electrons not used in bonding. So, sila yung tinatawag na lone electrons. Or kapag dalawa yung lone electrons, we can call it as lone pairs. Sila yung nakikita nyo na dalawang tuldok. Nariyan, may dalawang tuldok. Lone pair yun. Ang tawag dyan, pag dalawa, lone pair. Individually, ang tawag dyan ay lone electrons. Okay. So, sila yung mga hindi ginagamit for chemical bonding. Na? So, paano natin malalaman yung dami nila? So, the formula lang for U is I mean A minus S. Okay, so you subtract A and S. Ay, hindi kita tinatawag Siri. So, you subtract A and S, no? You subtract A minus S, then you will get the unshared electrons. And they can be used as lone pairs, no? Okay, so yan. Then after that, we're pretty much done with our structure. Okay, so ngayon, I will give you 6 examples for you to meditate with. No? Magme-meditate lang tayo sa mga examples since bago lang sa atin yung nasa rule para ma-appreciate natin siya. No? Number 1, CH4. Sige. So, CH4 tayo. Again, ano yung first step? You identify kung sino yung terminal, sino yung central. Central si carbon because hydrogen will always be a terminal atom. Terminal siya parate. Okay. Then you draw the skeleton. In the center, you have your central atom and around it, you have your terminal atoms. Ayan. Tapos ano na? Naso rule. Pagkagawa niyan, naso. Naso. N, needed. Okay. Dalawang atoms yan, so tignan natin. For carbon, for hydrogen. How many electrons ang kailangan ni carbon? Another way of asking that is, eto. Nagpo-follow ba ng octet rule si carbon? So, to verify kung nagpo-follow siya ng octet rule, tingin kayo sa periodic table. Andito sa P block si carbon. So, that should give you an idea that it can hold electrons na 8. Na? So, may 2 siya for the S, may 6 for the P. So, kaya niya mag-hold ng 8 electrons. Basta nasa P block, kaya mag-hold ng 8 electrons. Na? So, yun yung idea. So, that means for carbon, it can follow the octet rule. Kaya niya mag-octet rule. So, that's 8. Times ilan yung carbons natin? Isa lang. Na? So, 8 times 1. Again, bakit 8? Because nasa P block siya. Ganun lang. Okay? So, nasa P block siya, it can hold 8 electrons. Na? So, yun. H, how about hydrogen? Can it follow the octet rule or not? Pwede ba siya mag-octet or hindi? The answer is hindi. Why? Because it only contains one s orbital. And again, s orbital can hold 2 electrons only. So, ang needed niya ay 2 lang. Times 4. Bakit times 4? Kasi 4 yung hydrogens eh. Diba? So, to solve for the needed electrons, we just have to add them. No? 8 times 1 plus 2 times 4, 16 electrons. Okay, so we have 16 electrons in total. A, available. So again, when we say available, we are pertaining to the valence electrons. Valence electrons yung gusto natin. For carbon, what is the valence electron? Tingin tayo sa group niya. Bilangin natin. Group 1, Group 2, Group 3, Group 4 si carbon. So, since group 4 siya, that should give you an idea that there are 4 valence electrons for carbon. So, that means 4 times 1. Bakit 1? Isa lang kasi yung carbon. Bakit 4? Kasi group 4 siya. Okay? For hydrogen, ano kaya yung valence electrons niya? 1 lang. Bakit 1? Kasi siya ay nasa group 1. Ito yung group 1. Kasama siya doon. Okay. So, ayun. So, 1 lang siya. So, in total, ilan yung available electrons natin? 1 times 4 plus 4 times 1, edi 8 electrons na. So 8 electrons yung available sa atin. Ngayon, shared tayo, S. Ngayon, how do we solve for S again? N minus A lang yan. So that's 16 minus 8, which is 8 electrons. Or how many bonds? For you to know kung ilang bonds yan, you just divide it by 2. So you will get 4 bonds. Once you have 4 bonds, ano gagawin mo? You connect the atoms to the terminal. You connect the terminal atoms to the central atoms. So, isa, dalawa, tatlo, apat. Okay? Unshared. No? When you say unshared, ito yung mga electrons that are not used in bonding. Sila yung lone electrons. So, to solve for the unshared, that is A minus S. That's 8 minus 8 equals 0 electrons. So, wala tayong lone pair. No? So, yan. So, we're done. To verify if tama yung structure natin, you may want to check kung nasunod ba natin itong needed electrons. So how are we going to check yung needed electrons? Ganito. So, ingay ng... Wait. Tinatawag niya yung anak niya. So how are we going to verify kung ilan kung ano yung mga needed electrons? So ganito lang. Tingin kayo sa molecule. So ano gagawin mo? You're going to draw a border. Gawa ka ng border. Pili ka ng atom. Kunwari ito, gusto ko. Itong hydrogen. Gusto ko yung hydrogen. Sama yan. Gusto ko to. No? So yan. Ang gagawin ko. I will draw a border in which the bond attached to it is ma-enclose. Meaning masasaraduhan ng border yung bond na yan. So yan. Ganyan yung ibig kong sabihin. No? So itong border mo, sakop niya yung dulo ng bond. So I can do it here, here, and there. No? Okay. So ganun gagawin ko. No? So mamimili ka ng atoms, then you draw boundaries or borders. Yung dulo ng bond, sakop yon. Then you start counting electrons. Again, sabi dito, the needed electrons for hydrogen is 2. Bilangin natin kung ilang electrons meron dyan. For this hydrogen, may isang bond. And ilang bonds uli kapag ilang electrons kapag may isang bond? Dalawang electrons, di ba? Teka lang. Makulit yung mga baby ko. Ayan. So, yan. So, yung isang line na yan, that corresponds to 2 electrons, no? So, ibig sabihin yan, how many electrons are there around hydrogen? Hindi, dalawa. Ito yon. Ito, how many electrons are there around this hydrogen? Dalawa. How many electrons are there around this hydrogen? Dalawa. And how many electrons are there around this hydrogen? Dalawa din. So that means we satisfied the requirement for hydrogen na dalawang electrons. So after checking kay hydrogen, okay na siya. Carbon naman tayo. So gagawin mo, gagawa ka ng boundary wherein all the bonds kay carbon ay masasakop, no? Ganyan. Then you start counting kung ilan yung electrons surrounding carbon. So, ilan yon? 2, 4, 6, 8. Again, isang bond, dalawang electron. 2, 4, 6, 8. So, nasatisfy ba natin yung needed? Yes, no? Sabi dito, need ng 8. And ilang electrons yung meron sa kanya? 8. No? So, ayan. So, with that, we just verified na nakuha natin yung N, yung needed. So, our structure is complete na. Again, sa tingin nyo, feeling ko yung iba sa inyo, sir, parang mas madali naman yung ginagawa namin dati. Ganyan-ganyan. Parang di ba, mas madali yung ganyan. Mukha siya madali, pero later on, we will have more complex structures. Kaya hindi na siya applicable. No? Mas complex na yung structures natin mamaya. No? Okay. So that's for number 1. Let's proceed with number 2. Nh3 kunwari. Ammonia. Okay, so of the two atoms, sino yung central atom? Of course, automatically, nitrogen yon. Bakit nitrogen? Because again, hydrogen is our terminal. Terminal siya parate. No? Sa dulo yan parate. So, let's draw the skeleton. Yung tatlo, papalibot ko dyan. Okay? Then after doing the skeleton, nasu. Nasu. Ayan. Needed. 4 nitrogen, 4 hydrogen. For nitrogen, we need, nagpo-follow ba siya ng octet rule? Yung nitrogen, nagpo-follow ba ng octet rule? Anyone? You can use your mic kung gusto nyo. Yes. Now, it follows the octet rule because it is on the P block. Ayan siya, oh. Ayan, oh, yan yung nitrogen. So, since it is in the P block, then it should follow the octet rule now. So, 8 times 1. Hydrogen, alam na natin that it does not, it only requires 2 electrons. No? So, yan. So, 8 times 1 plus 6. 8 plus 6 cannot be 14 na. Cannot be. So, 14 electrons yung needed. No? Available. When you say available, we are pertaining to the valence electrons. Nitrogen is in group 5. Bilangin natin. Isa, dalawa, tatlo, apat, lima. So, it is in the group 5, no? So, balikan natin. So, 5 yung valence electron niya kasi nasa group 5 siya. Times 1 plus yung hydrogen, alam natin, group 1 siya. So, isa lang. So, 5 plus 1 times 3, that's 5 plus 3, 8, no? 8 electrons. Then, what's next? To solve for these shared electrons, ano gagawin dyan? N minus A. So, that's 14 minus 8 equals 6 electrons or how many bonds? 3 bonds. No? So, may tatlo tayong bonds. So, we can now attach our terminal atoms to the central. 1, 2, 3. Tatlo. Malapit na tayo matapos. Unshared. No? So, to solve for the unshared, the formula to be used is A minus S. Available minus the shared. No? So, to do that, you just subtract 8 and 6. No? 8 minus 6 is 2 electrons or how many lone pairs? When you say lone pairs, you divide it by 2 lang. So, 2 divided by 2 is 1 lone pair. May isang pair ka ng tuldok. Ito yung question. Kanino mo siya ilalagay? When assigning lone pairs, you place it first on the terminal atoms if it is capable. No? Kung capable siya tumanggap ng lone pairs. No? So, si hydrogen, can it accept lone pairs? Hindi na. Because tignan nyo, if I'm going to do this, itong border natin, hydrogen already contains 2 electrons. So, may tigdadalawa ng electron kay hydrogen eh. So, hindi na siya pwede tumanggap ng lone pair kasi dalawa lang yung kaya niya. No? So, that means, since hindi na natin siya pwede ilagay sa terminal, ilagay mo na siya sa central. Yan. So, yan. So, since nalagay na natin sa central, we can verify kung octet na yon central. Na-check na natin yung labas eh. And we just found out na may tigda-dalawa na for hydrogen. And that's good, no? Ngayon, si central naman. Again, we are going to draw a border surrounding all the bonds to nitrogen, no? Bilangin natin yung electrons. Isa, dalawa, apat, 6, 8. So, 2, 4, 6, 8. No? Again, one line corresponds to 2 electrons. So, nitrogen have 8 electrons around it na. No? So, that means we're done with the structure. Tapos na tayo. Okay, so that's how you use the NAS rule. Isa pang example, no? Mamaya na tayo mag-complex. O sige, mahirap, no? Pero nasusundan nyo na naman yung idea ng NASO rule. O, pag may question kayo, sabihin nyo na muna. Di ba paulit-ulit lang naman yung rule? Okay, so punta na tayo sa mga complex structures na. Let's say CO3. Hindi, wag muna yan. Ito muna, NO+. Okay, so typically, sa NO+, di ba dinodraw nyo yan nung bata kayo as ganito? Tapos, sabi nyo, hala, paano na? Wala na, stuck na kayo. Ayun yung problema, no? When doing Lewis structures in this manner, medyo magkaka-problem ka when it comes to charges. May charge yung molecule natin. So, paano na yan? So, hindi maganda yung ganitong way when writing the Lewis structure for charged particles. No? So, hindi natin yan gagawin. No? So, instead, NASO rule will help us. No? Makakatulong yung NASO rule sa atin. Okay. So, mas maganda yung NASO rule kaysa sa yung typical na ginagawa natin. No? Okay, so do we need to identify the central and the terminal atoms? This time hindi na. Ano lang yan eh. Dalawa lang yan eh. Magkatabi lang yan. No? Ay, tinulak ng pusa ako yung bintana. Marunong na siya. Okay, so no need na tayo to identify kung sino yung central and terminal atoms because dalawang atom lang yan. Side by side lang yan. Okay? Then we can start doing the NASO rule na. NASO. Hoy, Mingming. Yeah. Para ako may anak dito. Okay. So, N, needed. Okay, so needed tayo. For nitrogen, it follows the octet rule. So, 8 times 1. For oxygen, it follows the octet rule as well because it is in the p orbital. So, 8 times 1. 16 electrons yan. A, available. So, sa available, we are pertaining to the valence electrons. Nitrogen, 5 valence electrons times 1. Oxygen is in the group 6, so 6 valence electrons. Ito ngayon. Pagdating nyo sa available, pag nakita nyo, odd number yan. 11 yan eh. So, add yan, di ba? You may want to check your molecule una. Tignan nyo, may charge yung molecule natin. So, ano meaning nun? Meaning nun, kapag may charge, we have to alter our A. Babaguhin natin yung ating available electrons. Okay. So, whenever your molecule's charge is positive, that means you have lost electron. May nawala kang electron. Ilang electron yung nawala, edi kung ano yung charge na. Since ito ay positive 1, that means nabawasan ka ng isang electron. So you have to account for that sa NASO rule natin. So that means you will subtract 1 electron sa available. Kasi remember, the reason why we have charges is that may mga electrons na nawala kasi or nadagdag. Again, positive 1 yan. So that means may nawalang isang electron. Sa NASO rule, all we have to do is to subtract that lost electron. Minus 1 electron. So we will have 10 electrons na lang pala. No? So 10 electrons. Hindi na siya 11. Ito yung good thing with NASO rule. No? You can check kung ano yung nangyayari sa electrons by just looking at the charges. And with that, okay na tayo sa A. Siguro may magtatanong, Sir, paano po kapag negative yan? Kunwari, ganyan. Sir, paano po kapag negative? Ano meaning kapag negative yung charge? It means that there is an excess electron. May sobrang electron. Okay? So kapag may sobrang electron, anong gagawin mo? I-add mo yon sa available. So ang mangyayari dyan, 5 times 1 plus 6 times 1 equals 11 electron plus 1 electron. So magdadagdag ka ng isa to account for that extra charge. Okay? So ganun lang. Okay? So yan. S, shared. Again, the formula for shared is N minus A. So that's 16 minus 10, 6 electrons or 3 bonds. No? So that means between nitrogen and oxygen, there are 3 bonds. So saan ko sila ilalagay? Between them lang. Bawal ilagay dun ha, kasi walang atom sa kabilang side. Okay? Sige. Oh, unshared. Paano yung unshared? That's A minus S, di ba? So, A minus S lang yan. So, that's 10 minus 6, 4 yun, 4 electrons, or 2 lone pairs. So, you have to add 2 lone pairs. Ay, lobat na yung pencil. So, I have to add 2 lone pairs dito sa akin structure. Look at the structure muna, no? Saan ko ilalagay yung lone pairs? Siyempre, I will start with oxygen, no? So, siya yung electronegative atom, no? Most electronegative atom. So, there are already 6 electrons around oxygen, di ba? So, ilang lone pair kaya? Isang lone pair na lang, no? So, by adding 1 lone pair, ilang electrons na nakapalibot sa kanya? 2, 4, 6, 8. So, kompleto na yung kanyang octet. Ano gagawin sa isa pang lone pair? Tingin kay nitrogen. Baka dito siya iglagay. Ilang electrons na meron dyan? 6. Ilan pa kulang? 2. Or isang lone pair yung katumbas na. Okay? So by doing the Nasu rule, we can draw complex molecules such as charged particles now. So ayan. So ano lang yung kailangan i-keep in mind? So all you have to do is to ganito, no? Just check the charge. Ay. Napindot ko yung screen. Ano yung kailangan nyo gawin? You just have to check the charge. No? If it is positive in charge, that means you have to account for that. No? Kulang yung electron. So magma-minus ka sa available. Pag negative yung charge niyan, magdadagdag ka sa available. No? Okay, so yun lang yung idea ha. No, don't be confused with the signs. No? So yan. Baka kasi isipin nyo pag positive yan, magdadagdag ka. No, no. Electron po usapan dito. Okay? So, ayun. So, that's how you draw the Lewis structure for NO. May isa pa tayong example. Carbonate. Carbonate. So, ito naman. If you have question, you can tell me kung may question. May question po ba or okay naman? Nasusundan naman. Okay, so mukhang wala namang question. Sige. So, proceed tayo with CO3, carbonate. No? So, sino yung central atom? Kayo naman, tulungan nyo ako. Use your microphone to recite na lang. Tulungan nyo ako. Sino yung central atom? Sabi ng pusa ko, meow. Sino yung central atom? Anyone? Wow. Yes po. Si carbon. So, carbon is our central. Oxygen would be the terminal. Okay. So, I can draw the skeleton na, no? So, in the middle, I have my carbon. Then, around it, nandun yung oxygens. Kapalibot. Wag na wag nyo gagawin yung isang straight line sila, no? Yan. O, ku. Bawal din yung ku. Bawal din yung uk. Wag ganyan. Anong kailangan gawin? You surround your central atom with the terminal atoms. Palaging isusurround na. Paikutin nyo lang. Okay? Sanay naman kayo dyan. Then Nasu. Nasu. 4 carbon, 4 oxygen. For carbon, does it follow the octet rule? Yes. Kanina pa yan eh. So 8 times 1. For oxygen, ganun din ba? Yes then. Yeast na yeast daw, sabi nila, no? So, 3 carbon meron tayo. So, ilang electrons kailangan? 8, 16, 24, 32 electrons. Available. Valence electrons yon. So, for carbon, we have 4 valence electrons. For oxygen, we have 6 valence electrons kasi group 6 siya, no? Times 3 kasi 3 oxygens. So, ilan yan? 6, 12, 18, 19, 20, 21, 22 electrons. Okay, okay. So, pagkatapos ko dyan, anong gagawin ko? May nakalimutan ba ako? O, anyone? Ano yan? Nasulat ko na 22. Okay na ba ako dyan? Or may nakalimutan ako?
Hindi.
Ayun, nakalimutan ko yung charge, no? Look at my charge. I have negative 2 here. So, that means that I have excess 2 electrons. So, meaning nun, I have to account for that, no? So, lalagay ko yung dalawa pang electron. So, meaning ng negative 2, may dalawang sobrang electron. So, magdadagdag ako ng 2 electrons, making my available electrons 24 electrons. Plus 2 mo pa ninyo. Yan, 24 na. So, ganun ha. Pag negative yung charge, you add electrons. Pag positive yung charge, you deduct electrons. Yan, positive, nagbawas tayo. Negative, magdadagdag tayo. Ganun na. Okay? So, yan. So, magdadagdag tayo ng 2 electrons. And then shared. Paano uli yung shared? N minus A. So, ano yan? 32 minus 24 cannot be. 8, di ba? 8 electrons. Or how many bonds? 4 na bonds. No? So, yan. So, how are we, nabulol na ako, gugutom na. How are we going to place the bonds, no? So, yung 4 na bond, connect muna natin sila isa-isa. Anong gagawin sa sobra? You can form multiple bonds, no? Kunwari, gusto ko dyan yung sobra. Edi okay, so 4 yung bonds ko. Good yan. Then, unshared, no? So, when we say unshared, ang formula ay A minus S. So, A minus S. Ano yun? 24 minus 8. Ayan na naman yung aso. Nag-iingay na naman sila. Buti pa yung mga pusa na meow-meow lang. Okay. So, A minus S. 24 minus 8. 16. Or ilang lone pairs yan?
8.
Nag-mute sa akin. So, I have to distribute 8 electrons. No? So, i-distribute ko yung 8 electrons dito sa aking structure. O, tingin tayo dito. So, dito muna, may double bond. How many lone pairs ang kailangan for it to follow the octet rule? Ilang lone pairs ang kailangan ko ilagay? Dalawang lone pairs lang, no? So, yan. Isa, dalawa. Okay, so by counting, kung ilang electrons na meron, we have 2, 4, 6, 8. Again, yung isang line, katumbas nun ay dalawang electrons. So, 2, 4, 6, 8. So, kompleto na yung ating octet for that oxygen. Dito naman tayo. Ilang lone pairs ang kailangan dyan? Tatlo. So, dito na yung tatlong lone pairs, no? Then, let's verify kung walo na yung electrons around it. So, we have 2, 4, 6, 8 electrons. So, yan. So, may 8 electrons na around it. So, octet na yan. And yung nasa right side, ay left side pala. Same lang yan dun sa nasa taas, no? Basta same ng itsura. Same amount ng lone pairs. Okay, so na-distribute na ba natin yung 8 lone pairs? Bilangin natin. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 lone pairs na. Okay, so that means nagamit na natin lahat ng nasa NASU. All we have to do is to verify kung yung central atom natin ay naka-octet. Naka-octet na ba si carbon? Yes, no? So we have 4 bonds. 2 electrons, 2 electrons, 2 electrons, 2 electrons. So 8 electrons in total around kay carbon. So that means our structure is complete na. Okay? So bigyan ko kayo ng medyo brain teaser naman. HNO3, nitric acid. So, sige. So sa ngayon, sasamahan ko muna kayo, no? I want you to help me to identify sino yung central atom. Sino yung central atom? Is it the nitrogen, hydrogen, oxygen? Anyone? Ming. Sino yung central atom mo? Sino yung central atom? N, yung nitrogen. No? So, central atom ko si nitrogen. That means these two are my terminal, diba? Terminal, sila? Atoms. So, ganito. I have many ways kasi. Many ways to arrange this. No? Actually, dalawa lang. Ang pwede ko gawin is una, yung nitrogen nasa gitna, then yung tatlong atoms nakapalibot sa kanya. Pwede naman na yung oxygen ko, ilalagay ko sa dulo. Sa dulo ng, yung hydrogen ko, ilalagay ko sa dulo ng oxygen. So, yan. So, I have two ways of arranging my atoms, no? So, pwedeng nakapalibot sila lahat kay nitrogen or yung hydrogen nasa dulo ni oxygen. Pwede ba yun, sir? Pwede naman. Kaya nga may hydrogen bonding, no? The reason why we have hydrogen bonding is that hydrogen usually attaches with oxygen. Pero tignan natin kung possible tong letter A. Malay mo possible din yan, di ba? Okay, so that means we have to check sino sa dalawa ang mas tama, no? So how can we verify that? NASU rule, no? NASU. Erase natin. NASU. Needed for nitrogen, for oxygen, for hydrogen. No? Okay, so sige, NASU rule tayo. Needed for nitrogen is 8 kasi octet yan. Nasa p orbital siya. Oxygen, 8 din kasi octet yan. For hydrogen, dalawa lang again because s orbital lang yung meron siya. 8, 16, 24, 32, 33, 34. 34 electrons. Available, we are pertaining to the valence electrons. So, nitrogen, group 5, so 5 valence electrons. Oxygen, group 6, so 6 valence electrons times 3 kasi tatlo siya. Hydrogen, 1 kasi group 1 siya. Bilangin natin. 6, 12, 18, 24. So, yan. So, 24 electrons yung available. Since wala tayong charge, wala na tayong gagawin masyado. Na? Shared. Paano uli yung shared? N minus A. So, that's 34 minus 24. 10 yan. Or, how many bonds? 5 bonds. Okay? So, I have to distribute my 5 bonds dito sa atom. Okay? Sige. So, start ako sa taas. 1, 2, 3, 4. Saan ako pwede mag-double bond? Siyempre, bawal kay hydrogen. Kasi, it can only accept 2 electrons. Pwede ba ako maglagay kay oxygen? Dito din sa baba, gawa tayo. So, bawal ako maglagay ng double bond kay hydrogen. So, pwedeng dito, no? Saan pa ako pwede maglagay ng double bond? Gayahin ko lang yan. Si O, no? Pwede ako maglagay ng double bond dito sa taas. Sir, pwede rin dito sa gilid. That's the same as this one, no? Pinagpalit mo lang yung pwesto. So, yan. So, I have 3 possible structures pala. Oh my God. Ayan. So, huwag kayong magulat pag ganun. Kasi may sagot naman, no? Sige. In such cases na may 3 or more structures kang possible, may kasagutan dyan. Isa lang yung matitira. Yung iba dyan, impostor, no? Ayan. So, pwedeng, ito yung arrangement, lahat ng atoms nakapalibot kay nitrogen as yung bond, ayan. Pwedeng ganito naman, yung hydrogen nakadugtong kay oxygen. Okay? Then, ito yung bonds, no? Ano yung difference nito at ito? Yung double bond nito, na kay oxygen na bonded kay hydrogen. Ito naman, yung double bond niya na kay oxygen na walang hydrogen. So, magkaibang structure yan. And yun nga, may isang tama dyan, may dalawang impostor. Sino ang pwede natin i-eliminate agad? Emergency meeting. Sino yung impostor? Pwede tayo makapag-eliminate na eh. Isa muna yung eliminate natin. Is it gamitin ang cellphone, magte-text na, ABC. Sino ang impostor na pwede tanggalin agad-agad? A, B, or C? Sino? Any guesses? Any guess? Is it the molecule A na pwede na matanggal agad? Molecule B or molecule C? Any hula? A po. Bakit kaya A? Sige, Larry's Gen. Bakit A? Bakit din Janik? Mikhail. Basta yan. Bakit kaya A? Pinipili nila para sa mga wala pang idea. Di na po kasi nagpo-follow na Octet Rule. Ayun, no. So, looking at letter A, tingnan nyo, nitrogen, ilang bonds na meron sa kanya? 5 na. Again, Octet Rule lang. Octet Rule lang dapat, diba? Lumagpas sa octet eh. Tignan nyo. Gata ng border. Ilang bonds yung nasakop niya? 5. And again, every bond, 2 electron yung katumbas. So, may 10 electrons na around nitrogen. So, yan. So, sorry. So, hindi na siya tama. Kasi, it violated the Octet Rule. Na? So, yan. So, goodbye. A. So, we're left with B and C. May isang impostor pa dyan. Na? So, bago yan, sagutin muna yung task natin. Tapusin na natin yung task. Letter U, unshared. Again, how to solve for the unshared? That's A minus S. That's 24 minus 10, 14 electron or 7 lone pairs. So, I'm going to distribute the lone pairs. Na? Okay, so punta muna ako kay structure B. Dito kay oxygen na to, syempre walang lone pair yung hydrogen, di ba? Okay, so ilang lone pair pwede dyan kay oxygen na yan? Ilan yung kailangan para maging octet? Kailangan ng isang lone pair lang. Isang lone pair lang. Bakit? Kasi we have 2, 4, 6 electrons na. So, isang lone pair, magbibigay na yun sa atin ng 8 electrons. Okay? So, we're done with that oxygen. For this oxygen, ilang lone pairs yung kailangan? Tatlo. Because it already contains 2 electrons. So, dalawa na yung electron dyan, 6 pa kulang, or tatlong lone pairs. So, 1, 2, 3. And lastly, dito sa kabila, ganun din, no? Basta same ng itsura, same yan ng lone pairs. Provide na sakto yung lone pairs mo. Okay, so let's count if nagamit na natin yung 7 lone pairs. 1, 2, 3, 4, 5, 6, 7. Okay, so ayan, so it seems na okay na siya, no? Tignan natin yung nitrogen kung octet siya. Kasi dito tayo nagka-problema kanina. So, is nitrogen octet? Yes, no? Kasi we have 2, 4, 6, 8 electrons around nitrogen. So, ayan. So, mukhang okay siya, no? Mukhang okay. Okay. So, tingin tayo kay C. Baka si C yung matatanggal. So, tingin tayo dito. Ilang lone pairs kailangan niya? Ilang lone pairs kailangan yan? Dalawa. Since it already contains 4 electrons, it needs 4 more electrons or 2 lone pairs. Na. So we have 2, 4, 6, 8. So okay na yung octet rule natin. Itong oxygen na to, ilang lone pairs yan? Two din na. Because it already contains 4 electrons sa bonds. So kailangan niya pa ng dalawa pang lone pair or 4 electrons. And lastly, dito, may dalawa na doon. So, tatlong lone pairs yung kailangan niya or 6 na electrons. Bilangin natin kung sakto yung mga nagamit natin. No? 1, 2, 3, 4, 5, 6, 7. Then, okay, so since nagamit natin lahat ng lone pairs, tignan uli natin sa nitrogen kasi dito nagka-problema kanina. Octet ba siya? Octet naman. 1, 2, 3, 4. So, 4 na bonds or 8 electrons, octet. Ayan. Dito na, magkakatalo. Both structures seems plausible. Mukhang okay naman yung dalawa, di ba? Pero only one yung kailangan mag-remain. So, ibig sabihin, kailangan may tanggalin tayo dyan sa dalawang yan. Sino kaya? Any guesses muna? Any hula? Sino ang matatanggal? Si B or si C? Sayang, walang poll dito eh. Hula tayo. Wala nga poll. Any hula? B or si C? Wala pang mahulaan, no? Baka isipin nyo, baka pwede naman dalawa yung lumabas ng structure. Na kailangan isa lang. Okay. So, since ganyan yung problem natin, may kailangan tayo i-discuss na new topic, no? Ang topic natin ay stoichiometry. And formal charges. Okay. So, to answer our problem, we have to discuss the formal charge now. When we say formal charge, we are pertaining to the actual charge of an atom. Gusto natin malaman yung actual charge of an atom in a molecule, no? In a molecule. To solve for the formal charge, the formula is Fc equals should minus have. Sir, ano yan? Ano yung should? Ano yung have? Okay. When you say should, this is the electrons that your atom should contain. So, ano yon? Valence electrons lang yung idea niya, no? Valence electron yung idea. Yun yung should. Yung have, this is the electrons around the atom, no? Paano yan? Ganito. Kuha tayong simple examples. Okay, so paano natin gagawin yung formal charge, no? So ito yung ginagawa ko even until now. So bakit ko to ginagawa? Kasi mas madali siya maintindihan, no? Okay, ganito. If you want to determine how many electrons are there around your atom, all you have to do is to draw boxes. Alam ko naman, ganyan yung drawing ng box, no? Pero ganito, when we draw boxes, we make sure that we cut the bonds, no? Putulin natin yung mga bonds. So, ganyan yung ibig kong sabihin. Puputulin mo yung bonds. Okay, so bakit? Kasi ganito. Remember in your bonds, no, may electrons dyan, di ba? Okay. Yung isang electron, ay, hindi pala kita. Gamit tayo ng iba. Itong green na nga lang. Yung sa isang bond, di ba may dalawang electron dyan? One of the electrons kasi ay naka-hydrogen talaga and yung isa naka-carbon. So yung dalawang electrons dyan, no, magkahiwalay pa rin naman talaga sila. No? Yung isa nandito, yung isa andon. No? So the reason why we cut that is para maputol yung connection nila. So we can actually determine how many electrons are there around the atom mismo. Yung sa atom na mismo. Hindi yung shared na. Yung mismong dami ng electrons na nakay hydrogen na. So ganun yung gagawin natin. So the reason why we cut the bonds is that to see how many electrons are there talaga for your atom. No? Okay. So yan. So let's take the formal charge of this atom. So hydrogen, ano yung should niya? Ano yung valence electron? 1. 1 yung valence electron kasi group 1 siya. Ano yung have niya? When you say have, yun yung dami ng electrons that you can see sa box. Yun yung makikita mo sa box. Ilang dots yun? Isa. Isang electron. So yung have niya is 1. So 1 minus 1, 0. So for this hydrogen, 0 yung formal charge. No? And looking at all other hydrogens here, since they all look the same, that means 0 din yung formal charges nila. Okay, so ganun. How about this carbon? Carbon should minus have. Should. Ano yung valence electrons niya? 4. Kasi group 4 siya. Have. Ilang dots meron sa kanya? Ilang electrons meron sa kanya? Bilangin natin. Isa, dalawa, tatlo, apat. So there are 4 dots around carbon. So 4 minus 4, 0 then. So that means the charge of carbon is 0 as well. When you add all the formal charges, that should correspond to the charge of your molecule. So since CH4, wala siyang charge, that means pag pinag-add mo yung formal charges ng atoms, kailangan equal sila sa 0. And let's see. 0 plus 0 plus 0 plus 0 plus 0, edi 0. So, yan. Ano naman connection yan, sir, dito? Anong connection yan dito? Ayan yung gagawin natin. We are going to get the formal charges of this these two molecules. No? So, yan. Ano gagawin natin? So, dito naman tayo mag-focus. Gawan natin ng boxes yung atoms. Sir, do I have to do boxes talaga? Kailangan ko ba talaga mag-draw ng box? Not really. Pag sanay na kayo dito, visual nyo na lang, no? Titignan nyo na lang. Visual inspection. So, alam nyo na yung sagot, no? Pero for now, ganito muna tayo. Para simple lang yung approach, no? Kaya na yung mag-develop ng visual approach, na. So, ayan. So we have the two molecules. Binox na natin yung kada atom. Then we can start counting the formal charges. So let's begin with this hydrogen. Ay, hindi. Yung dots pa pala, nakalimutan ko. Okay, yung dots, pakita natin. Sir, kailangan ba talaga gawin yan? Hindi naman. For simplicity lang. Kaya ako pinapakita. Okay? So, yan. Para yung mga fast learner, alam na nila. Yung mga hindi ganun ka-fast, masusundan nyo, no? Kasi nakikita nyo visually kung ano yung electrons, di ba? Ganun. So, iba-iba naman kasi uri ng learners sa mundo, no? Ako, visual learner ako, so I really love seeing drawings, no? So, yan, no? Ito yung ating molecules. Binox na natin lahat and we showed the electrons na nasa bond. And those electrons are cut by the boundary of the box, no? So, looking at this hydrogen on the left, on the right, na ano kaya formal charge niyan? So, anyone who could help me? You can use your microphone na lang. Use your microphone na titingin ako sa people eh. So, hindi ko makikita yung chat niyo. Teka lang. Okay. So, yan. Raise your hand if you want to help me dito. Kay hydrogen. Ano kaya formal charge niya? Sige. Anyone? Sabi ni Kevin, 1 daw. Kevin ba yan? Bakit naging 1? Sabi ni Alusin ba to? 0 daw. Okay, so ano yung formal charge ng hydrogen na yan? So 0 yan. Bakit? Should. Ilan yung valence electrons niya? Isa. Kasi group 1 yan. Have. Ilang tuldok meron sa box na yan? Ilang tuldok meron sa box? Isa lang, no? So since isa lang yung tuldok, that means isang electron lang yan. So 1 minus 1 is 0. Okay? So 0 yung formal charge niya na. And dito tayo, oxygen. What is the formal charge of this oxygen? Oxygen naman tayo. Formal charge ng oxygen ay negative 1, 6. Formal charge ha. Yung pag pinag-add na. Okay, so paano yan, no? So, should, ilan yung should? 6. Bakit 6? Kasi group 6 yung oxygen. Minus have. Ilang dots meron sa box? 1, 2, 3, 4, 5. So, 5. 6 minus 5, 1. So, that means this oxygen will bear a positive charge na. Positive 1 yung charge niya. Okay? So, in-emphasize ko kasi kailangan niya mamaya eh. Nitrogen. Ano yung formal charge ni nitrogen dito? One. Bakit naging 1? Should is 5. Have is 4. Bakit 5 yung should? Kasi group 5 atom yan eh. Bakit 4 yung have? Apat yung dots around it. 1, 2, 3, 4. So that means nitrogen is positive 1 in charge, no? So yan, emphasize ko ulit. Kailangan natin yun mamaya. Dito na lang sa baba. Yan, so kain na daw. Tapusin na natin to. Okay, so oxygen, ano yung kanyang formal charge? Oxygen dito. Negative 1. Bakit negative 1? Kasi should 6. Bakit? Group 6 yan. Have, ilan yung meron siya? Bilangin natin. 1, 2, 3, 4, 5, 6, 7. So we have 7. No? So negative 1. So this will have a negative charge. No? And since this looks like this naman, so same lang naman sila ng itsura. So I will just copy the formal charge now. So yan. Okay, so those are the formal charges for molecule B. For molecule C, gawin uli natin yan. Yung hydrogen, alam natin 0 na yan, no? Parehas lang naman ang itsura eh. Yung nitrogen, they look the same, no? 5 minus 4. So, positive 1 yan. So, don't worry. Pag nasanay na kayo, i-mental nyo na lang yan, no? Okay. So, for this oxygen, what is the formal charge? Ito. Kunin nyo yung formal charge na ito. 0. Bakit 0? Kasi 6 minus 6 na. Should is 6, group 6. Have 1, 2, 3, 4, 5, 6. So 0. So wala siyang formal charge. Okay. For this oxygen, at the top, ang formal charge niya ay 0 din. Kasi 6 minus 6 din yan, ha? 1, 2, 3, 4, 5, 6. So 6 minus 6 is 0. Okay. How about this oxygen here? The formal charge is negative 1. Okay, so by just looking at your molecules, sino ang sa tingin nyo tama? B or C? C. Sabi ni Kevin, C. Sabi ni Larry, C din. Question, bakit? Okay. Ito kasi, no? When determining kung sino yung best structure, may guidelines sa, may guidelines kasi yung formal charges. Tignan nyo to. By the way, download nyo tong PDF na to. Andito lahat eh. So, tingin tayo dito. Saan yan? Ito, page 6 of 12. Sabi dito, sometimes there is more than one acceptable Lewis structure. In our case, dalawa. Bakit dalawa na lang? Kasi in-X na natin yung una. In-X na natin to. Ito yung acceptable. Kasi they follow the Octet Rule. Pero anong pasabi dyan? In such cases, we can often select the most plausible Lewis structure by using formal charges and the following guidelines. So that means may guidelines na susundin. Guideline number 1, for molecules with a Lewis structure in which there are no formal charges is preferable. Ang meaning lang yan is that as much as possible, the atoms with formal charges ay onti lang. That means hindi dapat lahat ng atom may formal charge. Rule number 2, if you have large charges, positive 2, positive 3, negative 2, negative 3, hindi sila ay acceptable. They're less plausible. Okay. So ano lang yung mga pwede? Negative 1, 0, positive 1. As much as possible, dun lang. Number 3, atoms with negative formal charges are placed on more electronegative atom. Meaning lang nun, if yung atom mo ay electronegative than the other, then it should contain the negative charge, not the positive charge. Okay? So, yun yung idea. So, tatlo yung rules natin. Number 1, as much as possible, onti lang yung atom na may formal charge. Kung kaya, is-zero lahat, yun. Pero wag is-zero yung score sa quiz dito. Okay? So, number 2, second rule, yung formal charges, no, as much as possible, maliit lang yung number. Dapat between negative 1 to positive 1. Negative 1, 0, positive 1. Rule number 3. Ano yung rule number 3? If you have an electronegative atom, sa kanya yung negative sign. Pag nasa kanya yung positive sign, X yon. Balik tayo dito. So looking at this, sino ang pwede na tanggalin? With all those rules, yung tatlong rules na nabanggit ko kanina. pwede na tanggalin si B. Kasi tingnan niyo si B, oh. Ilang atoms merong formal charge? 1, 2, 3, 4, apat. Dito, ilan? Dalawa. So, minus 1 point po sa kanya. No? 1 point para kay letter B. Ano pa? Tignan nyo si letter B. Yung oxygen doon. Ito. Tignan nyo yung charge ng oxygen positive. Eh, di ba yung oxygen yung most electronegative sa molecule? Then, it should not bear the positive sign, no? Hindi pwede yon. So, minus 1 na naman siya, no? Ano pa? Yung rule number 2, sabi doon yung guidelines, negative 1 to positive 1 lang yung charges. Eh, okay naman. So, wala naman tayong problema doon. No? But yun nga, molecule B violated yung guideline 1, which states that as much as possible, onti lang yung atoms na may formal charge. And guideline C, or yung katlong guideline natin, ang sabi doon, that the electronegative atom should always bear the negative sign, not the positive charge. Ito positive, X yan. Tsaka tingnan nyo, oh, may positive ka dito, may positive doon. Ano mangyayari? Repulsion. Hindi pwede yan, no? Magre-repel yung charges ng iyong atom. Sasabog yan, no? So, yan. So, that's the reason why B is cancelled. X yan. So, our final molecule is letter C. So, to draw the final molecule, dito, drawing ko na lang dito. So, ito na yung itsura ng final molecule natin. And then, yung formal charges, ilalagay nyo sila, no? At the end. No? Ilagay nyo kung saan atom yung formal charge. Ito negative, ito positive, no? So, ganun. So, this is our final structure for nitric acid, no? Ayan. So, we started with 3 different structures. Then, by using the Nh3 rule, we are able to eliminate A. By using the formal charge, we are able to eliminate B. And hence, we have this final structure for nitric acid. Ayan. So, tapos na tayo. Some info pa. Unti na lang. Upload ko rin itong mga pinagsasagutan natin. Don't worry. Dito sa chat box natin. Sabi ko kanina, di ba, na ang formal charge ng iyong atom, ang formal charges ng atom sa isang molecule, when you add them up, this should be equal to the charge of your molecule. So, let's look at carbonate, CO3, negative 2. Saan galing yung negative 2 na charge na yon? Kunin natin yung formal charge. No? Ito, mabilisan na lang ha. For carbon, ang should niya is 4 kasi group 4 siya. Ilan yung half niya? Ito yung technique. Bilangin mo na lang kung ilan yung dulo ng band na nasa kanya. 1, 2, 3, 4. So, 4. So, 4 minus 4, 0 yung formal charge niya. For this oxygen, ano yung formal charge niya? Should is 6 kasi group 6. Have ilan? 1, 2, 3, 4, 5, 6. So, 0 din, no? So, looking at this oxygen, 6 yung should. Have is 1, 2, 3, 4, 5, 6, 7 yung have. So, negative 1 yan. And this oxygen will also have a negative 1 charge. No? So, yun. So, ano yung sabi ko kanina? When you add up all the charges, they are equal to the charge of your molecule. No? Negative 1, negative 1, negative 2 yung charge na molecule. Okay? So, ganun yung tip. Burin ko na yung 0. Ayan. So, yan. So, negative 1, negative 1. Pag pinag-add mo yan, negative 2 yung charge ng molecule. And finally, para kumain na tayo, dahil ako ay nagugutom na rin, katulad nyo, sometimes we can violate the third guideline. Ano sabi ng ikatlong guideline? If your oxygen, if your atom is more electronegative, it should bear the negative sign. But not all the time. Say for example, this one, we have NO. Yan lang yung possible lowest structure natin, di ba? Tignan natin yung formal charge, no? Oxygen should is 6. Have, ilan yung have? 1, 2, 3, 4, 5. So, 5 yung have. 6 minus 5, positive 1 yung charge. For nitrogen, 5 minus 5, 1, 2, 3, 4, 5. So, 5 minus 5 is 0. So, walang charge yung nitrogen. So, as you can see, Oxygen here bears the positive sign. That's why the molecule is positively charged. Sir, di ba bawal yon? Oo, bawal. Pero wala na tayong choice, no? Nagkamali siya ng piniling partner. So, wala siyang choice. Mag-a-adjust siya. So, ganun yung idea, no? Not all the time, na-follow naman yung guidelines. Hindi parate, no? There are certain cases in which we can violate the guidelines, especially if we have no other choices, such as this molecule. Okay? So, that's the end of our first part of discussion for Lewis structures, no? Yun, no? So, I will upload the whole answers na ginawa natin sa Canvas. Ay, hindi. I mean, dito sa group chat, no? So, i-upload ko lahat ng info na kailangan nyo, no, for your notes, no? Do you have any questions? Or okay naman? Nasundan naman kahit paano? Or gutom na talaga? Nasundan naman? Okay na? None po? None question? Okay. So, sige. So, I think with that, na, if you have any other questions, just let me know. I will upload mamaya dito sa meeting chat yung yung answers. No? And may activity akong ipapagawa sa inyo. No? So, saan nyo ilalagay yung activity na yon? Go to your Canvas. Then, punta kayo sa discussions. Discussions. Then, yung sa atin. Ay, may nagpasa na sa section 3. Ay, sa section 22. So, sa inyo, section 23. Ayan, mag-comment lang kayo ng structure nyo. So, I will assign you some molecules to work with. Na? Okay, so with that, and so thank you very much for your participation. If you have any other inquiries, let me know. Message lang kayo dito sa